Hello, this is Mr. Stansbury. I'm going to take you through the notes on graphing two variable equations. At the end of this, you should be able to say, I can write equations in two variables to represent relationships between quantities. And I can graph equations on coordinate axes with labels and scales. Okay, so first thing, what is a function? Okay, a function is a relationship between two quantities, such as x and y, in which each input, x, has exactly one output, y. Probably the easiest way to explain this is to give you an example. So let's say here's our function here. We've got y equals 4x minus 3. Okay, I'm going to put this into what we call a function machine. I actually learned this in college and might just help you understand this a little bit better. So here's our equation, y equals 4x minus 3. Whatever comes out here is going to be what y equals. Okay, so what we do is we say, hey, let's say x equals 5. So 5 goes into this function machine and it replaces all the x's, right? So really what's happening here is this. I'm going to make this a little bit bigger here. So wherever we see an x, whatever goes into the function machine replaces all the x's. So that's really going to be 4 times 5 minus 3. So 4 times 5 is 15 minus 3 gives us 12. Okay? So now here's what a function means. Every time I plug in 5, I'm going to get 12 out, right? Every single time. There's no way to plug in 5 and get some other number out besides 12 unless I mess up my math, right? Okay. So since if I put a number, I'm always going to get the same output for each input. That means it's a function. Okay. If I were to be able to put 5 in here and one time it comes out 12 and the next time it comes out -2 or something like that, then that would not be a function. Okay. Okay. Let me erase some of that so we can see it better. The rate of change of a function is the ratio of the amount of change in the dependent variable to the amount of change in the independent variable. Okay, so that's a really big, long, potentially confusing sentence. For rate of change is simply the slope. Okay, so whenever you see rate of change, that's the slope of the function. That's what it's changing. Okay, and that's what this means here. Amount of change in the dependent variable, which is the y, to the amount of change in the independent variable, which is the x. Okay, so that is what we call the slope of the function. Okay, so for example, 37 miles per gallon, you have 37 miles per 1 gallon. So for every gallon of gas, you can go 37 miles. Okay, so that's considered the slope. Okay, so the miles that you can drive depends on how much gas you put in the tank. Okay, so if we were going to write a little equation here, this could be, say, distance is going to equal 37 times G, the number of gallons that you put in. Okay, so this 37 is the slope, which goes in right there, right before the independent variable. Okay. Next thing to talk about is slope-intercept form. Y equals mx plus b. Hopefully that sounds at least familiar. The m here is the slope, and then the b is the y-intercept. Okay, so that's slope-intercept form. We'll use that a fair amount. You use that a fair amount like the rest of your math life. So anyway, now let's do this. Let's take a look at some examples here. We're actually got just one big example here. Okay. Now, before we do this, let's take a quick little comedy break.
Come on, Chewie. Come on, Chewie.
AJ, fist bump.
Nope.
Okay. Let's see here. Marcia is planning on buying a pet pangolin. She has budgeted $300 for her purchase. Her pangolin cage feeding bowls and first month's food will all cost approximately $240, including tax. The remaining budget will be spent on toys for the pangolin, which average to be about $7 a piece, including tax. Okay. Marcia wants to know how the purchase of each toy affects her available money or available funds. Okay. Fill in the table and plot the points on the grid. So we know that she's got $300 available, right? And then the number of toys. Each toy cost $7, right? She already knows she's going to spend $240 right off the top, right? So if she spends $240 and she subtracts the cost of 0 toys, that is going to leave her with $60 left. Okay? Now if she starts with $240 and she subtracts 1 toy, which costs $7, that's 1 times 7 is 7, so 240 minus 7, it should be plus, right? 240 plus 7, and then we're going to subtract all of that minus, take that all the way from 300, so 247 minus 300 is going to be what? $53 less that she has. Okay? 300 minus 240, I really should have that in parentheses. You're following my drift, hopefully. Plus 2 times 7, that's 14, and 240 is 254. So basically, we're just subtract 7 from that, and that's going to give us, what, $46? Okay, 300 minus 240 and 5 times 7 is 35, and 240 is going to give us, what, 275, so that's going to leave only $25. And then 300 minus 240 plus 8 times 7, that's 56. So 56 plus 240 is 296, so that leaves $4 left over. If she does 300 minus the 240, oops, that's a 2, oh, that's bad. 240 and the 9 times 7, that's 63, and 240, that means that she's $3 over her budget. Okay? Okay, so fill in a table and pull out the points on a grid. So let's see. Number of toys is our independent. So number of toys. So let's just go 0 to 10. And then on this side here is going to be money available. So let's see. The most she could possibly have would be 60. So let's do, that would go up to 60 there. Let's make it easy. Let's just do that. Let's just do 20, 40, and 60 to go up to the top. Okay, and then we're going to graph these points. So 0 is at 60. 1 is at 53. So again, we're going to kind of have to guesstimate here roughly where it's at. 2 is at 46. 5 is at 25. Let's write it out in there. 8 is at $4. And really 9 is at -3. So it'd be like somewhere down here, huh? Okay. And then it's always a good idea to draw ourselves a nice little straight line that goes through those points. Get something kind of like that. Okay. And then part B says write a function that represents the amount of money that Marcia has left after purchasing T toys. Okay. So look, we've got our equation. We know our y-intercept is 60, and then we just got to figure out what the slope is. Okay. So write a function m of t. So the money that she has left according to how many toys she's bought. Okay, so we got m is going to equal some slope here times t, and then plus or minus whatever our y-intercept is. In this case here, we're starting at 60, so our y-intercept's 60. So if she buys no toy, she's going to have $60 left over. And then each toy takes this down. Since the slope is going down as we go right to left, it's going to be a negative number, right? And each one takes it down $7. So our equation should be the money she has left is going to equal -7. That's our slope, times t, the number of toys she buys, plus the $60 that she had left over from the total cost. Okay? What we're going to look at is write the slope-intercept form of the equation of the line through the given point with the given slope. So they give us a point and they give us a slope. So what we want to do is we want to use our point-slope formula. This is going to be our x1, this is going to be our y1, and our slope is also known as m in this equation here. Okay? So what we want to do is do y minus y1 is 5 here in this case, equals m, which is -1/2 times x minus -4. So we got the double negative turns into a positive. So we get y minus 5 equals -1/2 times x is -1/2 x. -1/2 times 4 is -2. Add 5 to both sides, and we get y equals -1/2 x plus 3. Okay, and that is the equation of the line that runs through that point that has this slope. Okay, one more last example is write the slope-intercept form of the equation of the line through the given points. So now they give us 2 points, no slope, but we'll have to actually go through and figure out the slope first, and then use one of the 2 points to plug into point slope. Okay, so officially it's y2 minus y1, so I do the little -9 minus -3 over -2 minus 1. That turns into positive -9 and 3. It's -6, -2, and -1 is -3. So that gives us a slope of 2. So that's our m, right? And then we can use either one of these 2 points. I'm just going to choose this first one here because it's only got one negative. Although the double negatives end up working out nice, but some people forget the double negatives. So let's do this, x1, y1. So if we plug it into our point slope formula over here, y minus our y1 is -3, so it's minus -3, equals our m, which is 2, times x minus 1. So we basically get y plus 3. Distribute this 2 through to both, and we get 2x minus 2. Subtract 3 from both sides, and we get y equals 2x minus 5. And that's the equation of the line that goes through these 2 points. Okay? All right, that's all we have for this. If you have any further questions, please feel free to ask. Thanks.